Okay, these notes are covalent bonding notes. A covalent bond is a bond where two elements share electrons. Now, we're not transferring them, we're just sharing them. In nature, there are 7 elements, okay, that you will not find as single atoms. They will be found in pairs, and they will always be in pairs. And they are called diatomic molecules. Okay. Okay, now let me list them. You have to know all 7 of them. They are hydrogen, which is H2, nitrogen, which is N2, oxygen, which is O2. You know, we breathe in oxygen, we breathe in O2. So that one should be very familiar to you. F2 is fluorine, chlorine, which is Cl2, bromine, which is Br2, and iodine, which is I2. Now, there's a cute little way to remember this. And yes, you will be quizzed on this. And you will not have your notes. You have to actually know them. And the best way to do this is to remember Hofbrinkel. See? Hofbrinkel. Hofbrinkel. So these are the Hofbrinkel elements. So when you hear other classes and hear me talk about Hofbrinkel, we're talking about the 7 diatomics. Now let's see what they look like. They tend to share, by the way. So these are all 7 of those, the diatomic molecules, share their electrons. Okay? We're not talking about ionic anymore. So let's look at H2. H2, there's 2 hydrogens, and I'm going to use 2 colors for each hydrogen. So there's a red one and a blue one. Now they both have 1 electron. Now, in order for them to be full, each hydrogen needs to have 2 electrons. So what they do, instead of trading electrons, they get together and they share the electrons. So 2 of them are for the first H and 2 of them are for the second H. Now, so the H's share 1 pair of electrons. Now this is a single covalent bond. And we like to write it a little differently. We write it as H line H. Okay, so that line represents the dash. So this represents, this dash here represents 2 electrons. So every time you see a dash in covalent bonding, there are 2 electrons in every dash. Okay, so Lewis structures. Lewis structures are pictures that use the element symbol and valence electrons with dashes to represent bonds and dots to represent unshared pairs of electrons. It's a lot like electron dot structures. In fact, you do use the electron dots in order to make the Lewis structures. Okay, so it's basically electron dot diagrams with dashes between more than 1 element. So let's look at F2. Now fluorine has 7 dots each. So we're going to put the fluorine here with 1, 2, 3, 4, 5, 6, and 1 there. And then another fluorine comes along. So fluorine needs 8. It's got 7. So 2 fluorines are going to come together, and you're going to have 2 dots in between it. So now you have this fluorine has 8 and this fluorine has 8. Now we write it like this with a dash. Now the dash is the bonding pair. Okay, those 2 electrons in the middle of those 2 circles are called the bonding pair. And then you've got to write the unshared pairs. So these are unshared pairs. And these are the bonding pair. So bonding pair of electron. So yeah, okay? Pretty easy so far, right? Now, chlorine, bromine, and iodine are pretty much the same. They have 6 dots around them with a dash in between. So chlorine will look like this. Okay, that's Cl2. Now Br2, bromine, looks like this. So that's Br2. And then I2 is this. Okay, because they have 7 electrons, so they each just share one pair of electrons with each other. Okay, they don't share anymore. Now oxygen's a little different. Oxygen shares 4 electrons, okay, 2 pairs, because each oxygen has 6 valence electron, and each one needs 2 more. So if you look at it, oxygen needs 2. So we're going to draw the electron dot structure. Okay, so what's going to happen here is these 2 and these 2 are going to get together. So you're going to have 2 pairs in the middle of the oxygens. Now, the Vesper theory says all the rest of the electrons are going to go as far away as possible. So that's why we kind of draw them like doggy ears on here. So this oxygen has 8 and this oxygen has 8. So we're going to rewrite it with 2 dashes in there because there's 4 electrons, and then we have our unshared pairs on the outside. Okay, so the double bond, this is a double covalent bond, and it represents 4 electrons, or 2 pair of electrons. Okay? Okay, nitrogen shares 6 electrons. Each nitrogen has 5 and needs 3 more. So if you look at there's the 1, and yes, I'm drawing them a little differently to show you where the electrons come from. Okay, so there's the 2 nitrogens. So there are 3 electrons. So this one has these 3 it's going to share. This one has these 3 it's going to share. So when it shares, it's going to look like this. So the 3 kind of line up there, there, and there. And this way, this nitrogen now has 8, and this nitrogen has 8. And we represented each of those 2. See, there's a pair, there's another pair, there's another pair. So we have now made a triple covalent bond, or triple bond. And each of the triple bonds is 6 electrons, or 3 pairs of electrons. Okay? Now, drawing Lewis structures for diatomic molecules is pretty easy. It gets a little more complicated when you have more than 2 atoms. For the next examples, you will need to look at covalent bonding hints and rules. Now, right now, you don't have a copy of it, but it is up on Canvas. So if you want to look at it, go ahead and take a look at it on Canvas. You will be getting it tomorrow in class, but I will be reading from it, so you may want to have it open. Okay. Okay, so let's look at the first example, CH3Cl. Now, if you look at your covalent bonding hints and rules, you have to make the skeleton first. So the rules are carbon is usually central. Well, we have a carbon. So we're going to make our central atom carbon. Okay? Now, hydrogen is never central. Well, so we know the H3, the hydrogen's never central. Oxygen is seldom central, but may link carbons, which we don't have to worry about. Okay, so we've now made the central atom. Now, steps for placing the valence electrons. Oh, before we do that, I probably should have put in the skeleton. You now need to add all the rest of the molecules around the carbon. So they all should go around the central atom. So I'm going to put the 3 H's and a Cl. And it really doesn't matter where you put that Cl. Okay, as long as you have 3 H's and a Cl around the carbon, you're fine. Now, in order to figure out where all the electrons go, we have to figure out how many, we have to calculate the total number of valence electrons. Okay, so I'm going to do that in red. Carbon has 4 valence electrons. Oops. So there's 4 there. Hydrogen has 1. So 1 times 3 is 3. So we're going to add that together. And chlorine has 7. So we now have 14 valence electrons. Okay, so we need to put 14 electrons around here. Well, first I'm going to count how many is around the central atom. Remember, every dash is 2 electrons. So I have 2, 4, 6, 8. I have 8 electrons around the central atom. Okay, and I need 14. So I got to put them somewhere. If you look for the steps for placing valence electrons, it says place the remaining electron in pairs to complete the octets of all outer atoms. So we're going to start with the outer ones first. Chlorine has 2, so it needs 6 more. Now, I'm going to stop there. We're not going to put any around hydrogen because hydrogen only shares 2. So there are never, ever, ever any dots around hydrogen. No, dots around hydrogen. Ever. Okay? So now I'm going to count my electrons. I have 8, so I've got 8, 10, 12, 14. I now have 14 electrons. So I am exactly right. So this is what the figure looks like. So it is, let's see if I can make my dots a little bit better. So this is the Lewis structure for CH3, or yeah, CH3Cl. Okay, let's try H2O. First thing I'm going to do before I even just do the central atom, the covalent bonding hints and rules is a good way to guess on it. I mean, it's a good way to have something in front of you, but I like to do things a little differently. I like to calculate the number of valence electrons first before I even figure out which one's the central atom. So here we have 2 hydrogens, so we have 2, and then we have an oxygen, which is 6. So I have 8 valence electrons. That way I know what I'm doing. Now, hydrogen can never, ever, ever be the central atom. So this one has to be oxygen. I'm going to put a hydrogen here and a hydrogen here. The reason why I do it like this is when we get to molecular geometry, you're going to see that this is really close to what water looks like. So I'm just going to put them there. Now, we don't put any O's, or any dots around the H's. So first we're going to see how many electrons we have. We have 4 electrons. So we're starting out with 4 electrons. So now I need to put 4 more because I need 8 altogether. Well, the only place I can put them is around the oxygen. And there's my 4. So now I have 8 electrons, which is exactly what I needed to begin with. So that is water. Okay, so let's look at the next one. Okay, so now we have carbon tetrachloride. So let's go ahead and count the number of valence electrons. So carbon is 4. Oops. Now, chlorine is 7, so it's 4 times 7, which is 28. So it gives us a total of 32 valence electrons. Now, carbon is always central whenever possible. And I'll give you another little hint. With chlorine, the chlorine, bromine, iodine, and fluorine never, well, not, I can't say never, when they're on the outsides, not when they're central atoms, but when they're the outside atoms, they won't ever form a double bond. So you can only put 1 dashes, and you might as well go ahead and put all of the electrons around it, and then go ahead and count your electrons. And when you count them, we have, if you go to the top one, you have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So we have 32 electrons, which is exactly what we're supposed to have. Now, COF2 is a little harder. So let's count the number of electrons we have. So carbon has 4, plus oxygen has 6, and then fluorine has 7, and there's 2 of them. So when we do this, we get a total number of 24 valence electrons. Now we know to put carbon central, and we're going to put an F here. I like to space them out on each side, and then I'm going to put an O up here. Now we've got to put all of the dots. So what you want to do is just fill up, make sure everything has 8, okay, and then count them. That's probably the best way to do it. When we count this, we get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 electrons. We have 2 extra electrons. Okay? Oops, there's a problem with that. Okay? We can't have 2 extra electrons. We have 24. So what's going to happen, since we have 2 extra electrons in our figure, we have to erase 4 of them. Now, we need to create a double bond. So 2 extra electrons means that there's 1 double bond. Okay? So, how we do this is you take off from the central atom, you've got to take off 1 pair. And then you've got to take off 1 pair from one of the 3 atoms around it. Well, we already know fluorine, Br, Cl, and I do not form double bonds on the outside. When they're inside, they do. When they're the central atom, they do. But when they're on the outside, they do not. So oxygen does. Oxygen does. Okay? Oxygen likes to form double bonds. So we're going to take away 2 of the electrons here, and we're going to put a dash. Okay? So now let's count our electrons. So now we're going to start with the oxygen. We got 2, 4, 6, 8. That double bond, remember, is 4. So 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So now we have 24 electrons. So we are fine. So this is the structure of the COF2. Now, there is such a thing called the 6n+2 rule. Guys, if this helps you, you can do this ahead of time. Otherwise, just do what I just did before, where you put all the electrons, and if it's got 2 extra, take out 4 of them to put a double bond. Okay? But if you don't want to do that, if you don't want to have to erase electrons, then you can use the 6n+2 rule. If the number of valence electrons is 2 less than 6n+2, there's a double bond. Oops, that's not a double bond. Double bond. If the number of valence electrons is 4 less than 6n+2, there's a triple bond or 2 double bonds. And what I mean by 6n+2, n is the number of atoms. So if you look again at COF2, okay, we have 4 atoms. So 6n+2 will be 6 times 4 plus 2, which is 26 valence electrons. And we had 24. So we had 2 valence electrons less than 6n+2. So I knew right away that it was a double bond. But as I said, these are the 2 ways you can figure out. I'll keep using the other way, and then I'll show you both, actually, if I can. Okay, now CN, which is cyanide, is a polyatomic ion. It's 2 elements covalently bonded together that's picked up an extra electron, so it has a -1 charge. So we actually have to count that when we count the number of electrons. So let's go with C is 4, N is 5, and the negative charge is 1. Now, if that had said a -2, it would be 2. We'd add 2 electrons. If it said a -3, that means it picked up 3 electrons. So here we have 10 electrons. Now, if you do the 6n+2, it's going to be 6 times 2 plus 2, which is 14 valence electrons. So we have 4 extra electrons, which means there's at least 2 double bonds or a triple bond. Okay? So that's using the CN+2 method. I'm going to show you how to do it if you still don't understand the 6n+2. So we're going to put carbon here and nitrogen here, and I'm going to put 1 here. Now, we're going to put all the electrons around it, and when we do that, we get 2, 4, 6, 8, 10, 12, 14. Okay, that's 4 too many. So for every time we have to take out 4, so we'll take out 4. So I'm going to erase this. We're going to take out 4 of them. Oops, come on. And every time we take out 4, we're going to put a bond in there. So there's a double bond. So let's count them again. 2, 4, 6, 8, 10, 12. So we still have too many. And actually, guys, whoops. We shouldn't have taken the back ones out. We should have left these. So we're going to hang on. Redraw it again. Okay, so once again, it's 2, 4, 6, 8, 10, 12. So now we're going to take out 4 more. Remember, for every time we take out, for every 2 electrons we have extra, we have to take out 4 to put another line in there. So now if we do this line, it's 2, 4, 6, 8, 10, which is exactly what we have. Now, remember, it picked up an extra electron. So we have to draw brackets. The brackets indicate it's a polyatomic ion. That means it's got a charge. Okay? So hopefully you understood that. I'll explain more tomorrow, if you don't understand about. Okay, let's look at CO2. Now I'm going to do the same with CO2. I'm not going to worry about the 6n plus 2. You guys, if you understand how to use the 6n plus 2, use it. I'm going to show you without using it. Okay, so carbon is my central atom. Oops, first let me count. We have 4 plus 2 times 6, which is, let's see, 12 plus 4 is 16. So we have 16 valence electrons. So now I'm going to put a carbon with 2 oxygens. And I'm going to put all the dots around them. And then I'm going to count them. And I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I have 20 electrons. Well, that's too many. That's 4 too many. So for every 2, we need to put another dash in there. So I know I need 2 dashes somewhere. I either make a triple bond. So since I'm 4 over, I need 2 dashes. Okay? Because remember, every dash has 2 electrons. So I need 2 dashes. So I've got 2 oxygens. I'm going to tell you right now, oxygen does not like to make triple bonds. O does not do triple bonds. Okay? And since I need 2 dashes, okay, I'm going to put them in between here. Now to do that, I had to take away some electrons. So I got to take away 2 here, 2 here, and 2 here. So now let's count them again. I have 2, 4, 6, 8, 10, 12, 14, 16. I have exactly what I need. Okay? So just remember, every time you put a dash in, you got to take out 4 electrons, because each dash is 2 electrons. I don't know, it's really hard to explain, but each one is putting in the electrons. Okay, so you got to take away 2 for each part of the dash. But each dash is technically only 2 electrons. But what you're representing is, yeah, it's hard to explain. Just know that what I would do is just put the dashes in and then make sure everything has 8 electrons accordingly. Okay, that's probably easier. So for every 2 that you're over the number of electrons you have, when you put all the electrons down, then you put a dash, and then just erase enough so that each of the atoms has only 8 electrons in between. Okay, so that's it for tonight. So I will explain more tomorrow. We'll practice tomorrow with it. We'll play a lot. We'll do a lot of we'll draw a lot of Lewis structures so you guys understand it. So bye.